Tonight we're going to be talking about systems of equations and how we solve systems of equations. What are systems of equations? When we talk about a system of equations, keyword being system here, we're actually talking about when we have two equations or more. Sometimes it is more. So we have more than one variable and we have more than one equation. The reason that we have to have systems, groups of them, is anytime you have two variables or two things that you don't know, you need more than one equation to solve for it. We need a situation where we can figure out, okay, where do these two variables work for both of these situations, and then that would be a solution. So when you are solving systems of equations, we need more than one variable and more than one equation. We can have 3 variables and 3 equations, or 4 variables and 4 equations, but be aware that to solve a system of equations, for every variable, for everything you don't know, you need an equation to solve for it. So if I only have 2 variables, I only need 2 equations. If I have 3 variables, though, I'm going to have 3 equations. So the number of variables needs to be the same as the number of equations in order to actually be able to solve for those equations. So the number of variables needs to be equal to the number of equations in order to actually solve for it. Particularly for this unit, we are going to be focusing on linear systems. So we are going to be just talking about lines, straight lines, but you can have systems of equations with other types of equations, and we'll see those as we go throughout the school year. But right now we're going to focus on linear systems, so linear equations and linear inequalities. When we are talking about a system of equations, what you need to remember, again, is that we're just talking about 2 variables in the same equation, and we're already used to dealing with that. We've been doing y equals mx plus b for a while now. So this is an equation, and it has more than one variable, specifically usually x and y. So y equals 2x plus 7, or y equals 1/3 x minus 8. You know, we've been dealing with these linear equations. So these equations have 2 variables, and that's why you can't just solve for x in this situation. That's why we end up with a line, because if you recall, this line, all these points, all the points along the line are the x and the y values that work for this equation. They're all the combinations of x's and y's that work for that particular equation. If I have this line, and it's the collection of all of the points that work in that particular situation, all the x's and y's that you get for this particular equation. So when we look at a system of equations, what we're saying is that we want to find the x and the y that happen to be the same in both of these situations. So I want where are the x's the same in these two and the y's the same in these two. In other words, I'm looking for a point that works on this line and a point that works on this line. And that means that when we are solving systems of equations, we're looking for a shared point. Another way to say a shared point is that you are looking for the point of intersection. The solution to a system of equations is a point of intersection. It has an x value and it has a y value. So you're looking for the point of intersection. This means that we actually have 3 different types of systems of equations. You have the system of equations that actually intersects one another. And when they intersect each other, they intersect at a point. So there is one solution because they intersect at one point, and we generally call these independent systems because each of the lines are just kind of doing their own thing. It is important to note that intersecting lines always have different slope. So if you have 2 lines and they have different slope, then you know they're going to intersect somewhere. And so we know we're going to have a solution. Somewhere, this had a slope of 2 and this had a slope of 1/3. I may not know exactly where, but I know they're going to intersect somewhere and that they're going to have a solution. So we like those systems. They're nice, neat, easy to do. Another situation, though, with lines, if you remember, you can have lines that are parallel to one another. And whenever lines are parallel, that means that they don't intersect. So they have no solution. There's not going to be a single point where these two lines ever touch one another. They just go off and they never touch. It's also important to remember from last unit, parallel lines have the same slope, but they also have different y-intercepts because they do not start at the same place, but they are moving the same direction. So they have the same slope, but they have different y-intercepts. They're never going to touch each other. Same slope, they're never going to touch each other. We call these inconsistent. So there's a little bit of vocabulary here that you're going to want to keep up with. Inconsistent are the systems that don't have a solution. So you want to watch out for those. They're the little tricky ones. And then last but not least is sometime after we graph two different lines, they started out as two different lines, but then when we graphed them, they actually ended up being right on top of one another. They ended up being the same line. If they end up being the same line, they don't intersect at just one point. They intersect at all of their points. And so they have an infinite number of solutions. Now, that doesn't mean that all real numbers is the solution. Not every number works. But there is an infinite number of solutions because all the points on this line are going to work. It is important to note that if they're the same line, they have the same slope and the same y-intercept. They have the exact same y=, form. And so they would have infinite solutions. So when you're solving systems of equations, you're not always going to just get one answer. It's possible that there's no answer. And it's possible that there's an infinite number of answers. So you want to watch out for those when you're solving them. As you may have noticed, that since the solution to a system of equations is a point of intersection, then the first obvious way of solving these systems of equations is by graphing. So solving by graphing is going to be our first option for solving systems of equations, because we graph them and then we look for where they intersect. Whatever point is where they intersect, that's going to be our solution. So if I'm going to graph, I need my little grid here, so let me get my grid. All right, and so let's look at a system of equations. Let's say that I have y = 3x - 1, and I have y = -2x + 9. And this system of equations, I want to solve it and figure out where do they intersect. So things I need to remember about graphing: this is our y-intercept, and the number in front of the x is always our slope. We'll continue this in a moment.